So I know we finished this one yesterday. This is the one we finished on. Now I feel like for the most part y'all feel comfortable with sum and difference of perfect cubes and dealing with difference of perfect squares and everything we covered so far yesterday. I want to skip the next one and look at this one here, the last sum and difference of perfect cubes, because it is a little bit different than the ones we've done, or the ones we did yesterday.
No, she told McLennan that. He was like, oh wait, no. That's funny.
So awkward that it was humorous.
That's funny. He's like, so was she monotone? Was she like, you have a good smile? No, she's like, oh, I like your smile. That's so pretty.
Was not prepared for it. So we're going to look at this here in the other type of factoring, and then we're actually done with this chapter, or factoring chapter, whatever we want to call it. Now I do want to look at this one here before we move on to factoring by grouping, because it is a little bit different in that the variable is second instead of being first. Now it's not going to really change anything, it's just going to look a little bit different. So the first thing we can do is take the cubed root of both terms. Now the cubed root of 125 is 5. And the cubed root of x cubed is x. So that lets us know that we can, or not that we can, but that this is a difference of perfect cubes. And now when we look at the signs are going to be the same, opposite, always end on a positive note. So since we're starting out with a subtraction, our first sign is going to be the same. So subtraction, addition, because it's opposite, always end on a positive note. So the same, opposite, always end on a positive note. So we're going to go negative, positive, positive. Now, between the 5 and x, well, which one came first? The 5. So we plug this in, the 5 is going to go first, since 125 came first. Then inside the bigger one, we're going to have 5 squared, 5 to the first, and then 5 to the 0, which is just 1, and we don't have to include it, because we're going to have a variable or another term plugged in. Now, x, since it came second, will go second. Then we'll have x to the 0, x to the first, and then x squared. So when we simplify this here, our first one is going to be 5 minus x times 5 squared is 25 plus x squared. Now we could rewrite the second one as x squared plus 5x plus 25, because we can reorder those variables just fine. I'd be a little bit hesitant to do it with the 5 minus x, because if we rewrote it, it would be negative x plus 5. It's a little odd having a negative x plus 5. It looks a little bit better to just leave it as 5 minus x. But either one of these here would be the correct factorization. Any questions on this here? All right. let's look at the last type of factoring that we have, and that is factoring by grouping. Or another way that I think of this here is greatest common factor twice. Now, the way that we look at this here is factoring by grouping is that we're going to group these together and factor it that way. So what we can do is we can look at the first two terms and the second two terms, because there's 4 of them, and we always want to group them in even amounts or group them in the same amount. So since here we have 4, we can do 2 and 2. We won't want to do 3 and 1. We want to have an even number for both groups. So this does work for more than 4, because we could have 6 terms, so I could group it 3 and 3 or 2, 2 and 2, any way that it's an even amount. Now what we want to have happen is after I factor something out of both of these groups, we need it to be the same. We're aiming for the what's inside the parentheses to be the same. Now if I look at this first set here, 2p cubed and 5p squared, is there a greatest common factor between the two? Well, there's not a number, but what do they do have in common? P squared, because the first one has 3, the other has 2. So I can factor out ap squared. I can pull 2 of those variables out of both. If I pull 2 of them out of 2p cubed, I'm left with 2p. If I pull 2 of them out of 5p squared, I'm left with plus 5. Now let's look at the other one. Is there a greatest common factor between 6p and 15? 3. And it would be positive. So we can say plus 3. And if I factor the 3 out of 6p, I'm left with 2p plus 5. Any questions on what we did so far? Now doing that gave us 2p plus 5 inside the parentheses. Factoring out the 3 gave us 2p plus 5 in the parentheses, yes? Are both of those the exact same? So this is where I call this greatest common factor twice, is because we pulled out a greatest common factor once out of both of them, yes? Well, it shows me that I do have now a greatest common factor of 2p plus 5, because we can treat it as one term and factor it out completely. So if I factor out the 2p plus 5, well, what am I left with? In the first one, I'm left with p squared, and in the other one, I'm left with 3. And that's it. Now we need to make sure that neither one of these will factor further. Now, I didn't mention this yesterday or either the days before, but whenever we look at this here, we're looking at the degree of each one of those. There's really one way that we can check. The 2p plus 5, well, the degree is 1. So it is as simplified as it can get, because if the degree is 1, we're good. If we look at the other one, p squared plus 3, the degree is 2. So that one we do need to look in and make sure that it can't factor any further. And well, p squared plus 3, we would be looking at hopefully a difference of perfect squares if we have it, but it's not a difference, it's a sum. So there's no way to factor it and have rational roots. So this is as far as we can take it. Does that make sense? I mean, if we wanted to, it technically could be p plus I square root of 3 times p minus I square root of 3 if we wanted to go that route. But again, just like how I showed you guys yesterday with the plus or minus 3i, we'd actually have to solve it and then work backwards to find out what it would be. And this here is the accepted completely factored. Any questions on this here? Now, the only reason I would have, or someone would have you go that extra step, is if they, instead of putting completely factored, is finding all the complex factors also, then we would have to go and find those. or the irrational factors, because the square root of 3 would be irrational. But this here is completely factored. Any questions on this here? 3n cubed minus 4n squared plus 9n minus 12. So when we're looking at these here, now for the most part, the ones we'll deal with aren't going to be too bad or too difficult. But sometimes, especially when we're looking at these here, the way that we group them may not always be as big of a deal, but we still try to keep them together. Because I'll normally try to work with these two and these two. Now we could rearrange them in different ways and eventually still get to the same conclusion. So 3n squared and minus 4n squared. Sorry, 3n cubed minus 4n squared. The greatest common factor is n squared. And if we factor that out, we're left with 3n minus 4. So after we solve the first one, we need to find a way to factor something out of the 9n minus 12 and get 3n minus 4. So what can I factor out of that? Positive 3. If I factor positive 3 out, I'm left with so 3n minus 4. It'd be multiplied by n squared plus 3. Any questions on this here? Let's look at this one here. So we'll look at this one here. This will be the last one we look at. I also think this is the last one on the note sheet. Yes? Now, 224AZ plus 56AC minus 84YZ minus 21YC. So let's look at the first two first. If we're looking at these two here, what number and variable can we pull out? Well, the variable might be easier to see. A, we can factor out an A. Because we will need Z and C. Eight. Well, that's a little challenging, isn't it? Trying to see what factor we want to pull out of those two numbers. Let's look at the other two then. Because we know that Y will be for sure, yes? Now, our first two here, these two here are both what? Positive, yes? These two here are both negative. So what do we know also has to come out? Negative. Because if I factor that negative out, it'll make both of those positive. Okay. Now looking between these two here, well, 21's factors are 1 and 21, which really doesn't help us, or 3 and 7. Now is 84 divisible by 3? Is it divisible by 7? Is it divisible by 21? Is 84 divisible by 21? Because 21 times 4 is what? 84. That's kind of interesting, isn't it? What is 224 divided by 56? So, if we factored out 21, negative 21 from here, negative 84 divided by negative 21 is 4z minus, well, 21 factored out completely, the negative factored out completely, so this is positive, and all we're left with is c, yes? So let's come back over to the other one here. So we need this to be 4c plus, or 4z plus c, yes? So I need this here to be 4z plus c. Because for these to be able to do factoring by grouping, I need those two sets of parentheses to be the same. (56a). Because it does work out that 224 divided by 56 is 4. And then we would have the z, and the 56a would factor out, completely leaving us with just c. So sometimes working with this factoring by grouping, looking at the first two, we had some difficulty seeing what we needed to factor out. But looking at the second two, okay, we could see that a little bit clearer. We factored it out and saw how we could make the first one be the same. So sometimes grabbing the first two is not always the easiest. Then we can factor out that 4z plus c, which leaves us with 56a minus 21y. And that's it. Now I will also say with factoring by grouping, sometimes looking at the first two and last two, it's kind of hard to see what the grouping would be. So we could always do, say, the first one in third, second, and fourth. We can do these in any combination and see if we can find one that works. Luckily, for the most part, we can do 2 and 2 and get there. Any questions on this here? And that's it.